Hey, what up, guys? It's Ryan with Brainstorm. So, when you learn scientific notation, it kind of makes sense to know, like, why did they even invent this thing in the first place, right? That's like half the problem with math is kids are always like, what? Why am I learning this? And this is what scientific notation is for. Scientific, this is an issue for scientists. And so that's why scientists came up with this notation. Because look, what if you had a number like bacteria count and it was like 27 bajillion, like whatever, this huge number, right? Or if it's like the concentration of iron in the blood is 0.000000. And like after a while, if you were to write these numbers like over and over, it would get old. You'd be like, this is just too big of a number. All right, fine. The number 7 is fine to write, but the number 27, bazillion, it gets ridiculous. So they decided, hey, we need to figure something out to make this way shorter. And what they came up with makes actual sense. It's called scientific notation. And the rules of scientific notation are it's a digit, then a decimal, and then the number of digits after can change. It could be 1, 2, 3, 4, and it's always times 10 to the something, right? And so that's what gives it its power, right? And so we're going to look at these two, and we're going to convert them into scientific notation, but the rule is one digit, then a decimal. If you have 2 digits and a decimal, it's wrong, right? And I'll show you, for example. So this first guy right here, we know that 27 billion, right? It's this. You see this decimal, it's after the first digit. Where is the first non-zero digit? 2. So it's 2.7, right? Times 10 to the something. So we're already off to the correct start. It can't be 0.27 times something. It can't be 27 point. It has to be one non-digit number and then the next guy. So it's 2.7. Now, the rule is if this is a huge number, the exponent above the 10 is a positive number. Is 27 billion a huge number or a tiny number? It's huge. So this is going to be positive. And what number goes here? What exponent? You count to the decimal. So where did my decimal end up? I put it here at the 7. So how many times did I move to get there? Watch this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So this is a 13. Notice this is not just the number of zeros. It's the number of times I move to get to my final destination, which is between the 2 and the 7. Weird? So the decimal started here. Remember, when there's no decimal, it's at the end. And it moved 13 places to get where I put it. So this is 2. So this would be written as 2.7 times 10 to the 13th. Weird? All right, so now let's do this tiny number. Right, we know the rule is that it has to be a non-zero digit and then the decimal and then another one. Well, if this is 46, that has to be 4.6, right? There's no other option. It can't be 0.46 times 10 to the something. It can't be 46 times 10 to the something. It has to be one digit, then a decimal, and then another digit. Okay, so we have 4.6 times 10 to the... Now, quick question. Is this a tiny number or a huge number? 0.000000, that's a tiny number, way less than 1. This isn't even as big as 1. It's like 1 billionth of 1. So this is a tiny number. So before I even start, I know that my exponent up here, actually, let me give myself some more room. I know that my exponent's going to be a negative. I don't know what it is yet, but I know that it's going to be a negative value. Now, I ask myself, the number is how many times I move my decimal to get to my final destination. I want it after this 4, before the 6 here, so let's move it there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So this is equal to 4.6 times 10 to the negative 16. Is that crazy? So the larger this exponent, the more it moved, in other words. And the cool thing is now that you know the rules, you can glance at this right away. This, honestly, if you're a scientist, would you rather write this number or this number, right? This number or this number. And you can glance at it and say, wow, that's a huge number because the exponent is positive and big. This one you can say, wow, that's a tiny number because the exponent is negative and big, right? So this is very, very tiny. All right, so let me just give you a quiz. Those are the rules, and let me just give you a quiz. Okay, and here's 2 numbers, and your job is to put them into scientific notation. First thing you should notice is, hey, this better have a positive exponent. This better have a negative exponent. I can't mess that up because I know that's a big number, positive exponent, small number, negative exponent. Okay, so now, all right, I know the rule. It has to be 1. It can't be 29.8 and some stuff, right? It can't be 0.298 and some stuff. What's the rule? It's one digit, so it's 2. Then the rest of the digits behind the decimal. So that's the first step. Okay, so that's right. So it's 2.98 times 10 to the what number? Again, we know it's positive, but where is it? The decimal has to end up between the 2 and the 9, and it starts at the end. So 1, 2, 3, 4, 5, 6, 7, 8. So this would be written as 2.98 times 10 to the 8. Notice I included all my non-zero digits. I just made sure they were in the right place. A whole number, the decimal, then the rest of the whole numbers. All right? Okay, so that's that one. What about this one? Okay, it's going to be a negative, but so who cares? I still have to start with 6.4. There's one number, then the decimal, and then whatever's left, times 10 to the what? So this one is going this way, so let's move it so it ends up here. 1, 2, 3, 4, 5, negative fifth. And I knew it was a negative before I even started my problem, right? Okay, pretty good. Let me give you a couple more. And you should be like good enough to be like already knowing which one has a negative exponent, which one has a positive exponent. Look, this is a pretty big number. You know, don't you wish you had that many dollars? That's a big number. You don't wish you had this many dollars. That's like way less than a penny, right? All right, so cool. So whatever, I know that it's going to be 8.5. It has to be. There's no other option. 8.5 times 10 to the what? Let's move it. 1, 2, 3, 4, 5, 6. So negative 6. It doesn't stop here. It doesn't stop here. It stops between them, and we knew that, right? Okay, cool. What about this one? So it has to be 3.6. There's no other option, right? Times 10 to the what? It's going to be positive. I know that. And where's my decimal now? It's at the end, so let's move it. 1, 2, 3, 4. So that's 3.6 times 10 to the positive 4. And again, looking at this, how much money do you want? This guy has a positive exponent. He has a negative. This guy's bigger. Okay, now weirdly, what about putting these? So now that we have like a grasp on how to put a number into scientific notation, what happens when you have scientific notation and you want to put it back into what's called standard form or the normal form? So check that out. So here's two numbers, and we're going to do that, right? We're going to say, okay, well, I'm glad it's in scientific notation, but now I want to put it back in a standard form so I can see it. And right away, before we do it right, I can show you how you mess up. Some people try to memorize, if it's a positive exponent, I go to the left or the right, right? It's some dumb trick. Don't memorize it. Just know this. Is this a big number or a tiny number? Because that's to the positive 6, this better be a big number. If I get this, 0, 0, 0, 0, 0, if I do my work and I get that, I know I'm wrong. This is a tiny number. That doesn't work. That's a positive exponent. Same thing here. Is it large or tiny? This better come out to 0.0000, some bunch of zeros, and then 49. If I get like 49 million, I know that's wrong because it should be a tiny decimal. So that's a hint. Okay, so the way to do this is, so you write your 3.5, and remember, 6 is how many places I move it. So let's move it. Ready? 1, 2, 3, 4, 5, 6. And what goes in the empty spots? Zeros right here. Perfect. And sure enough, if I write this, I would have 3, 5, 0, 1, 2, 3, 4, 5. Right? And then if I put in my commas, this would be my number. And yes, I must be right. Is this a tiny number or a huge number? It's huge, so I think I got it right. Okay? This one, 4.9. And now I'm going to move it how many places? 7. And I'm going to move it to the left, making it a tiny decimal, right? So 7 to the left. 1, 2, 3, 4, 5, 6, 7. There's my decimal. And these all get zeros in them. So my answer in standard form would be this. That was converted back. So yeah, if you learn how to go from standard to scientific, you just do the opposite to go back to standard. But it can be tricky. So I think really the way that kids mess up is they try to memorize left, right, whatever, and they don't look at the big picture. Just always remember that a positive exponent is a huge number, negative exponent is a tiny number. And yeah, scientific notation, not gonna lie, it's kind of handy when you're writing huge numbers. All right, good luck, you guys.